The solution to these problems is a progressive web app, or PWA. A PWA isn't a new language or framework you have to learn from scratch. Instead, it's a set of modern web development standards and best practices that progressively enhance a standard website, giving it powerful, app-like capabilities. It's the best of both worlds, the reach of the web with the features of an app. To understand how this works, we'll explore its three foundational pillars. The entire philosophy of PWAs is built upon three core pillars: reliability, speed, and engagement. These principles guide every decision in PWA development, ensuring the final product delivers a superior user experience that feels seamless and integrated. Think of these pillars as the checklist for transforming a website into a true PWA. Let's start by breaking down the first and most crucial pillar: reliability. First up is reliability. A reliable PWA loads instantly and never shows the no internet screen, even on flaky networks or when completely offline. This is the biggest departure from a traditional website. It means the core user interface, the shell of your app, is always available, providing a consistent experience users can trust. This magic is made possible by a technology called a service worker, which we'll dive into shortly. Building on that reliability, the second pillar is speed. Users today have high expectations. Over half will abandon a site if it takes more than 3 seconds to load. PWAs are designed to be incredibly fast. They achieve this by intelligently caching resources to minimize network requests and by prioritizing the loading of critical content first, so the user sees a meaningful interface almost instantly. On repeat visits, a PWA can feel as fast as a native app. The third and final pillar is engagement. A PWA shouldn't just feel like a document, it should feel like an integrated part of the user's device. This is achieved through features that were once exclusive to native apps. PWAs can be installed on the home screen, they can launch into their own full-screen window, and most importantly, they can send push notifications to re-engage users with timely updates. Now that we understand the what and why, let's explore the how, the core technologies that power these pillars. To make a website installable and engaging, we first need to give it an identity. This is the job of the Web App Manifest. It's a simple JSON file, usually named manifest.json, that you link to in your HTML. This file tells the browser everything it needs to know about your app: its name, the icons to use, the colors for the theme, and how it should behave when launched from the home screen. Let's look at a basic example of a manifest.json file. The name and short name properties define what users see in the install prompt and on their home screen. The icons array provides different sizes of your app icon for various device resolutions. The start URL tells the browser which page to open when the app is launched, and background color provides a splash screen color for a smoother transition from tap to launch. Beyond identity, the manifest also controls how your PWA looks and feels once launched. The display property is key here. Setting it to standalone tells the browser to launch the app in its own window, hiding the browser's address bar and UI for a truly immersive app-like experience. The theme color property allows you to style the toolbar or status bar to match your brand, further blurring the line between your PWA and a native application. With our PWA's identity defined by the manifest, it's time to introduce the engine that powers its reliability and speed, the service worker. But before we can even use a service worker, there's a critical, non-negotiable prerequisite. Your application must be served over HTTPS. This is a security measure to ensure that the connection is encrypted, preventing man-in-the-middle attacks. Because service workers are so powerful, browsers enforce this rule strictly. So what exactly is a service worker? It's a special type of JavaScript file that your browser runs in the background, separate from your web page's main thread. Think of it as a programmable proxy that sits between your application, the browser, and the network. This unique position allows it to intercept, inspect, and respond to every single network request made by your app, giving you complete control over the connection. A service worker doesn't just start running. It follows a well-defined lifecycle with 3 key stages: registration, installation, and activation. This lifecycle ensures that new service workers can be installed safely without disrupting the user's current session. Understanding this process is crucial for managing updates and ensuring your PWA behaves predictably. Let's walk through each stage, starting with registration. The lifecycle begins with registration. In your main application's JavaScript, you'll add a small piece of code that checks if the browser supports service workers and then calls navigator.serviceworker.register, passing the path to your service worker file. The browser then downloads this file and prepares to install it. This registration step only needs to happen once, and the browser will handle checking for updates on subsequent visits. Once registered, the browser triggers the install event in the service worker. This is our first opportunity to run code. The most important job during installation is to cache the essential assets that make up your application's user interface, often called the app shell. By using the Cache API to store these files, HTML, CSS, JavaScript, and key images, we ensure the core of our app can load instantly on the next visit, with or without an internet connection. Let's pause to clarify what we mean by the app shell. The app shell is the minimal HTML, CSS, and JavaScript required to power the user interface of your application. It's the static frame, like the navigation bar, header, and overall layout, that remains consistent across different pages. By caching this shell, we can load it instantly from the cache, then populate the dynamic content later from the network or a different cache. This architecture is key to perceived performance. After a successful installation, the service worker enters the activate event. This stage is primarily for housekeeping. Its most common use is to manage caches. For example, if you've updated your app and created a new cache for your app shell, the activate event is the perfect place to safely delete the old, outdated caches. Once activation is complete, the service worker takes full control of its pages and is ready to handle events like fetch. With the service worker active and in control, its true power is unleashed through the fetch event. This event fires every single time your application tries to make a network request, whether it's for an image, an API call, or another page. Inside the fetch event listener, you can write logic to intercept this request and decide what to do with it. This is where we implement the caching strategies that make our PWA reliable and fast. Now that we can intercept requests, we need a plan. These plans are called caching strategies. There are several common patterns, and choosing the right one depends on the type of resource you're handling. For the app shell and other static assets that rarely change, the cache-first strategy is ideal. Let's see how that works. In a cache-first strategy, when a request comes in, the service worker checks the cache first. If a matching response is found in the cache, it's served immediately to the app. No network request is ever made. This is incredibly fast. If the resource isn't in the cache, only then does the service worker go to the network to fetch it, and it will typically add the response to the cache for the next time. This is perfect for the app shell, fonts, or logos. But what about content that changes frequently, like a user's profile data or a newsfeed? For that, we use a network-first strategy. Here, the logic is reversed. The service worker first tries to fetch the resource from the network to get the freshest possible data. If the network request succeeds, it serves the response and updates the cache. If the network fails, because the user is offline, it then falls back to serving the last known version from the cache. This prioritizes freshness while still providing offline access. A third, very popular strategy offers a fantastic balance between speed and freshness: stale-while-revalidate. With this approach, when a request is made, the service worker immediately serves the version from the cache, making it lightning fast. At the same time, it sends a request to the network in the background. When the fresh data arrives, it updates the cache, so the next time the user requests it, they'll get the updated version. The user gets an instant response now and fresh data for later. Now, let's connect everything back to that engaging pillar. When a browser detects that a website has a valid web app manifest and a registered service worker, it recognizes it as an installable PWA. The browser may then proactively show an install prompt or an icon in the address bar, inviting the user to add to home screen. This is a huge step as it elevates your web app from a browser tab to a first-class citizen on the user's device. Once installed, we can leverage another powerful feature for engagement: push notifications. Because the service worker runs in the background, it can listen for messages from a server even when the app isn't open. When a message arrives, the service worker can wake up and display a system notification to the user. This is perfect for things like chat messages, breaking news, or order updates, allowing you to re-engage users at just the right moment. What about when a user tries to perform an action while offline, like sending a message or submitting a form? Traditionally, this would fail. But with the Background Sync API, the service worker can detect the failed request, save the data locally, and then automatically retry the request once the network connection is restored. This creates a seamless experience where the user can interact with the app, confident that their actions will be completed eventually. Of course, none of these advanced features matter if the app doesn't look good on every device. A fundamental requirement for any PWA is a responsive design. The user interface must fluidly adapt to any screen size, from a small phone to a wide desktop monitor. Using modern CSS techniques like Flexbox, Grid, and media queries isn't just a suggestion. It's essential for providing the consistent, high-quality experience that users expect from an app. With all these moving parts, how can you be sure you've built a proper PWA? Thankfully, browsers provide excellent developer tools, most notably Lighthouse, which is built into Chrome. Lighthouse is an automated auditing tool that can run a series of tests against your site. It generates a detailed report on performance, accessibility, and most importantly, it provides a PWA checklist, telling you exactly which criteria you've met and what you still need to fix. So where do PWAs fit in the ecosystem? They occupy a unique sweet spot between traditional websites and native apps. They have the discoverability and linkability of the web, no app store required. But they also adopt the reliability, performance, and engaging features that made native apps so compelling. It's a powerful combination that offers a single code base to reach users on any device with a modern browser. In summary, building a progressive web app comes down to a core recipe. You start with a secure foundation by serving your site over HTTPS. You give it an identity and an app-like feel with a web app manifest. And you power its reliability and advanced features with a service worker. By combining these technologies with a responsive design, you create a next-generation web experience that is fast, installable, and deeply engaging. The journey doesn't stop here. The web platform is constantly evolving, with initiatives like Project Fugu adding even more native capabilities to the web, such as file system access and contact pickers. By mastering PWAs, you are not just learning a new technique, you are investing in the future of the web, a future that is more capable, reliable, and accessible to everyone on any device, anywhere in the world. Now it's your turn to start building.